Let's take a look at topic 5.1, example 4. We're going to simplify nth roots. So in other words, just various roots, we're going to start simplifying them. So here we go. We have the fifth root of 32m to the 15th. Now, how you want to think about this is notice your index. You have an index of 5. Could you write this radicand with a power of 5? If you can do that, then your root is going to cancel out that exponent, and whatever you have in parentheses is going to be your solution. So let's take a look. So right off the bat, can I write 32 with an exponent of 5? Why, yes, yes I can. I know that 32 is 2 to the 5th. Now I still have the m to the 15th. Can I write m to the 15th with an exponent of 5? Well, let's think about it. Is 15 divisible by 5? Yes, it is. So that means I could write this as the fifth root of 2m. 15 divided by 5 is 3. And then if I raise all of that to the 5th power, these are equivalent. Now again, we kind of did our properties of exponents backwards. When you have a power to a power, you multiply. To kind of undo that, you would do the opposite, you would divide. So now let's take a look. If I redistribute this 5, 2 to the 5th power is 32. M to the 3rd raised to the 5th power, 3 times 5 is 15. So here we are. I have not changed the value at all. I have just kind of rearranged it, rewrote it in a way that is going to be meaningful to me for this situation. Now, notice here, you have your index of 5 and this exponent of 5. These two will cancel each other out, which means you can bring this, what's in the parentheses, out of the radicand. So your answer here is 2m to the 3rd. Now let's take a look at another one. B, we have the fourth root of x to the 20th, y to the 8th. So I don't have any coefficients. Let's ask, is 20 divisible by 4? Yes, it is. Is 8 divisible by 4? Yes, this is going to be nice and easy. Now we also have to keep in mind here, you see how we have a root of 4? Don't forget, your answer has to be positive. So if we get odd exponents, we need to use absolute value bars. So let's take a look here. I'm going to go ahead, let's do the radicand, the radical, my radicand. Okay, so 20 divided by 4 is 5. So that means I can have x to the 5th, and then my base of y, 8 divided by 4 is 2. And then I'll raise all of that to the 4th power. And again, notice if you redistribute, you do your power of a power property, x raised to the 5 times 4, 5 times 4 is 20. And then y squared raised to the 4th power is y to the 8th. And now here we are. My index matches this exponent. They cancel each other out. They're inverse operations. And so my answer here is x to the 5th y squared. However, don't forget, this could potentially be negative if you have an odd exponent. My answer, because my root was even, my answer has to be positive. Now, y squared, no matter what, my answer will be positive. You can raise a negative number to an even power, you're going to get an even answer. But here in this case, potentially not. You can raise a negative number to an odd power and it still remains negative. This needs to be positive, so I'm going to put what it has a negative exponent. I'm going to put absolute value bars around it. So this is my final answer. Here are your triads. Go ahead, give them a shot, pause the video, and then come on back and let's check. Okay, so here we go. This might seem a little tricky because you have a negative under the radical, but again, notice you're on a cube root. Here, negatives are allowed. We don't have complex solutions here. So what we want to know, can I write each of these factors, a -8, an a to the 8 cubed, and a b to the 9th, can I write them with an exponent of 3? Well, here we go. Put my radical in, my 3. So let's tackle -8. Can I take, is there a number that I can raise to the 3rd power and get -8? Well, that would be -2. -2 cubed would be -8. And now when you have variables and exponents, well, let's see, can I divide a to the 3rd? Can I divide 3 by 3? Well, yes. 3 divided by 3 is just 1, so keep the base, exponent of 1. b to the 9th, 9 divided by 3 is 3, so b to the 3rd. And then what I'll do is I will raise everything to the 3rd power. And again, remember, if you redistribute this 3, -2 raised to the 3rd power is -8. A raised to the 3rd power is a cubed. B cubed, or b to the 3rd raised to the 3rd power, 3 times 3 is 9. Okay, and now here again, your index matches your exponent. These cancel each other out. Your answer is right here. There's your final answer. On B, now again, notice you have an even root. So if you end up with any odd exponents, we need to use absolute value bars. Okay, so let me put in my radical. And I have an index of 4. Is there a number that if I raised to the 4th power, I would get 256? Okay, well, 4 raised to the 4th power is 256. I'm going to write the 4 there. X to the 12th. Is 12 divisible by 4? Yes, it is. 12 divided by 4 is 3. I'm going to put x to the 3rd there. Y to the 24th. 24 divided by 4 is 6. Raise that all up to the 4th power. And then notice again, your index matches that exponent. They will undo each other. And this, what's in parentheses, can come out from the radical. So your answer is 4x cubed y to the 6th. But again, don't forget, you have an even root. Your answer must be positive. I could put a negative number in for x here and it would stay negative. So in order to fix that, make sure it's positive, I'm going to put absolute value bars around it. Y to the 6th, that's an even exponent. Anytime you raise a number negative or positive to a positive exponent, your answer will always be positive.